Hello, grade 7. So this is the physics answers to worksheet 2. I hope all of you are safe. Please do these questions as these are a nice summary questions to what we've been doing in semester 1. So question 1 is about solid liquids and gases. So we have to indicate the correct statements and correct the false ones. So the free surface of salt in a box is always plane and horizontal. Please, plain and horizontal is always with liquids, so salt is not a liquid, so obviously this statement is false. The free surface of a liquid in a box is always plain and horizontal. You can put any liquid if you like, because here they name salts. You can write orange, water, orange juice, water. All of these work. Solids have a definite volume. They are fluids that can be transferred from one container to another. No, solids cannot be, they're not fluids first of all, and they can't be transferred from one, they can, but they don't take the shape of the container. So false, liquids are the ones that have a definite volume. They are fluids and can be transferred from one container to another. Rice, lentils or sugars are example of powdered solids. This is true. Mercury is a liquid, then mercury has a definite shape and volume. First of all, mercury is a liquid, okay. Then mercury has a definite shape. Remember, liquids take the shape of the container, so that means their shape keeps on changing, so therefore they do not have a definite shape, they have an indefinite shape. Therefore, it's wrong, they have an indefinite shape but a definite volume. Question 2 says, the two containers below are connected by a narrow tube. This is the narrow tube. Draw the level of the free surface of the liquid in the second container. Remember, this is a communicating vessel. So the communicating vessels have a surface, first of all, which is horizontal and plane. As you can see here, the free surface of the liquid is horizontal and plane, and also they're at the same level. So if here is the level, we get the ruler. Okay, now I can't draw a straight line on here. I did this, and then you just draw it at the same level of the first container. Okay, so it's like this. Okay, obviously you use a ruler and you draw a straight line. Okay, because the free surface is horizontal and plane, and they have to be at the same level because these are communicating vessels. Okay, this is really important. Question 3, mass of a solid. To determine the mass of the piece of modeling clay, this is the modeling clay, we named it C. The student used instrument X as the figure below shows. So this is instrument X, and we want to find out the mass of this clay. First of all, we have to give the name of the instrument X. So what's the name of this instrument X? Say 2-arm ballots. Find the mass of the piece C. So we have to find the mass of this. There we go. Because the two plates are at the same horizontal level, this is the masses. These are the combined mass for this piece of clay. Remember, whenever we find the mass, you always have to write M equals, mass is M. M equals 50, so there's 50, 26, plus 46, plus 26. So what's 50 plus 26 plus 46 plus 26? This is 148 grams. Okay, so please always write units, because we've got grams here. We have to write grams. Indicate the SI unit of mass. Remember, SI means System International. What's the System International unit of mass? It is kilogram. Then number 4 says, convert the mass obtained in 2, so here question 2, to the SI unit of mass. But we've here got grams, we want it to the SI unit of mass, and we said the SI unit of mass is kilograms. How do we go from kilograms to grams? Okay, remember we divide by 1,000. Okay, so from grams to kilograms, we divide 1,000, therefore we do 148, the answer that we obtained. In question 2, we divide it by 1,000, so it's 0.148 kilograms. Name another instrument to measure mass. We can measure mass using a digital balance. Question 4 is mass of liquid. To determine the mass of a liquid, we perform the following measures. So here we've got a cylinder or a beaker, and we take the weight of it, and then we filled it with water, and then we take the weight of it again. Remember, we know that this is the weight of the beaker because the needle indicates at 0, okay? So here, first of all, we have to calculate M1. You should know that M1 is the mass of the beaker. Okay, this is really important and you should know this, mass of the beaker. So what's just the mass of the beaker? This is 20 plus 20 plus 10, which is 50 grams. And then we've got to do M2. Remember, M2 is the mass of the beaker and water. So this is M2, this is M1. So what's the mass of the beaker and water? This is 20 plus 50 plus 5, which is 75 grams. We have to determine the mass of the liquid. Use this equation, M equals M2 minus M1. What is M2? It's 75 grams. What is M1? It is 50 grams. Therefore, the mass of the liquid is 25 grams. Now, question 4, convert the following. I gave you a lot of conversion questions. This is because we need to practice, okay? So, I'm going to write something for you to help us. Ton, from kilogram to gram to milligram. Okay, we're going to use this as our basis. I'm not going to write times 1,000, divide 1,000 because you should know. So we've got 140 grams. We want to change this into kilograms. So from grams to kilograms, we divide by 1,000. So what's 140? So 140 grams divide by 1,000. Remember, we move 3 times to the left. It's 0.14. If you want to write the 0, I don't mind. We've got ton into kilogram. How do you go from ton to kilogram? You times 1,000, so you've got 0.072. Okay, if you times, you move to the right. How many times? 3 times, because 1,000 has 3 zeros. Once, twice, 3. So that is 72 kilograms. Then milligram into grams. How do you go from milligram into gram? We have to divide to 1,000. Divide 1,000. So you've got 427 milligrams. You have to divide by 1,000, so you move to the left 3 times. 1, 2, 3. So it's 0.427. Then we've got kilograms into milligrams. How do we go from kilograms into kilograms? It's really important. First of all, we have to go from kilogram to grams. So that's times 1,000. And then from gram to milligrams, that's another times 1,000. So that's 1 million. Okay, so how many times? So look, we've got 0.0134. Okay, first of all, use this point here. We have to times 1,000, then times 1,000 again. So we have to do 6 zeros. Okay, so 1, 2, 3. So now we went from kilogram to grams, but we now have to go from grams to milligrams. So another 3. 1, 2, 3. Remember, when we have these eggshells, we have to put eggs in them, zeros, alright? So then the answer is, we ignore the zeros at the front. It is 1, 3, 0.400. That's how we go from kilograms to milligrams. More conversion questions. I'm going to write this again from ton. So we go tons, kilograms, grams to milligrams. Please, this you have to revise. 143,000 grams into tons. How do we go from grams to tons? We have to go from first grams to kilograms, so we have to divide 1,000. Then we have to divide by 1,000 again. So we have to divide by a million. So we've got 143,000. So we're going to want to go from grams to kilograms, from kilograms to ton. So we move how many times? 6 times. 1, 2, 3. So now we've converted from grams to kilograms. Now we have to convert from kilograms to ton. 1, 2, 3. Remember, our point is now here, so we have to put a 0 at the front. So the answer is 0.143. 37.64 kilogram into grams. How do you go from kilograms into grams? You times by 1,000. So I'm going to do this here. I'm going to write the answer here, okay? So because I don't have space. 37.64. We have to times by 1,000 to go from kilograms to grams. 1, 2, 3. So the answer is, remember there's an eggshell here, so we have to fill it with a 0. So the answer is 3,700. Sorry, 37,640. Okay, so this is the answer to this one here. And then we have 0.056 ton into kilogram. How do we go from ton to kilogram? We times by 1,000. So here we have 0.056 ton. We have to times 1,000, those 3 times to go from ton to kilograms. 1, 2, 3. So this is 56 kilograms. 5.98 kilograms into tons. How do we go from kilograms to tons? We divide by 1,000. So 5.98 kilograms. We have to divide by 1,000. So 1, 2, 3. Remember we put a point, 0.00598. Last but not least, what is the last? 32,100 milligrams into milligrams. Aha, you see, when it's the same, we keep the same result. Please, this really confused you in class. You keep it the same. 32,100 from milligrams to milligrams, it does not change. So 32,100. I hope this helped. Okay, please practice with conversions. Okay, this was a nice summary. If you need any help, obviously we'll go through it into class. And I hope you're all safe. Please take care. And bye for now.